I'm BARISH from ECE department, and today's topic is the environmental impact of electronics manufacturing. So let's take a quick look at the topics that we will be covering today. So what are electronics? Demand of electronic components. What is Industry 4.0? How is electronics manufactured? The hazards of electronics manufacturing, the reports and fines, ISO 14001 certification, and a guide to cleaner electronics. So what are electronics? Electronics is a branch of physics that deals with the emission, behavior, and effects of electrons, as in electron tubes and transistors and with electronic devices. EMS is a term used for companies that design, manufacture, test, distribute, and provide return or repair services for electronic components. So let's take a look at the demand of electronics components. The consumer electronics market size has been growing over the past few years, from 2018 to 2022. Its annual growth rate averaged 7.65%. The biggest growth in this period was seen in 2020, when the industry's revenues soared 20.64% year over year. India consumer electronics market revenue from the year 2020 to 2030. As visible from the graph, there is a 6.5% of compound annual growth rate, or CAGR, in the Indian market from the year 2022 to 2030. Alright, so now let's take a look at the largest electronics companies based on revenue. The first being Apple, the second being Samsung, the third being GHORAI, and the fourth being QI. So what is electronics manufacturing process in production? Alright, so the first process being design. The first step in electronics manufacturing process is design. Now this is where professional engineers come up with plans for the devices. They create prototypes and they test them to see if they will work. Next is sourcing. The next step is sourcing the components from others in the electronics manufacturing industries. This can be done by suppliers that are present all over the world. The third, assembly. At the assembly plant, as we all know, the components will be put together and they will be combined by professional workers and machines. The fourth is packaging and shipping. After testing, the devices are sent for packaging and shipped to retailers or consumers. The fifth is eco-friendly initiatives. Now, as we all know, the electronics manufacturing process, there is a lot of byproducts, hazardous products that are continuously being produced, and they need to be managed, because of which some companies have taken eco-friendly initiatives towards a greener future. Let's talk about Industry 4.0. Industry 4.0 is a very new term, and it refers to the fourth industrial revolution and is the cyber-physical transformation of manufacturing. This is revolutionizing the way companies manufacture, improve, and distribute their products. Manufacturers are integrating new technologies like IoT, cloud computing, analytics, AI, machine learning into their production facilities and throughout their operations for more production and to meet the demand of the market. These are basically smart factories which are using autonomous robots, simulation, system integration, IoT, cybersecurity, cloud computing, additive manufacturing, basically the use of 3D printers and metal printers, augmented reality or VR, and big data. Embracing Industry 4.0 is imperative for electronics manufacturers. Today, electronics design, manufacturing, assembly and distribution is one of the world's largest industries, and it continues to expand rapidly with the advent of technologies that are being adopted by consumers in everyday lives. But the electronics industry itself can benefit from the innovations it's fueling. By combining physical manufacturing operations with big data, AI, and machine learning, along with other technologies that support real-time automation and information gathering, electronics companies have turned recent progress into what's now being referred to as the Industrial Internet of Things, IIoT, or Industry 4 for short. So let's look at the challenges that are faced in the electronics manufacturing process. A few of them are rapidly changing technology, short product life cycles, access to raw materials, environmental regulations, labor issues, sustainability, and end-of-life management. The four materials that illustrate hazards of electronics manufacturing. Now there are a lot of hazardous substances that are involved in electronics manufacturing, like lead, which is widely used in soldering, halogenated flame retardants, TBBPA, which is a halogenated flame retardant used as a raw material to manufacture printed circuit boards, PVC, polyvinyl chloride to insulate electric wiring, etc. But there are these four materials that are widely used and that can prove really harmful for the environment. The first being benzene. Making electronics usually involves combining many small or very thin and minute components that all need to be very clean and precise. That's part of the reason the industry uses so much water. It's also why manufacturers use solvents like benzene, a very common industry clean and unknown carcinogen. Benzene also occurs naturally in crude oil deposits. When consigned, Department of Health Services notice warns that benzene leaks can quickly contaminate groundwater, which can prove really harmful for their new civilizations. Next is copper. Copper is a very common metal that's found just everywhere. It's being used by humans for millennia and is really essential in many industries. Depending on manufacturing techniques, copper is also used for quite a few components that are part of an LCD screen, from circuit board etchings to small motors. But too much exposure to this metal through inhalation, ingestion, or skin contact can cause health problems that range from minor issues like headaches and nausea to more serious matters that include kidney and liver damage. The next is nitrogen trifluoride. Now, fluorine is used industrially to clean and treat surfaces to make them resistant to water and fingerprints. Now, it can be obtained from nitrogen trifluoride, a synthesized chemical that is also a potent greenhouse gas. Nitrogen trifluoride comprises a tiny portion of these gases in Earth's atmosphere, and over the years, electronics manufacturers have adopted other methods of generating fluorine. Ironically though, the electronics industry initially took the chemical as a way to reduce its climate footprint. But researchers say the level of nitrogen trifluoride in the atmosphere is still increasing, and electronics manufacturing is the only known source. Indium. Now, indium is a relatively sparse element that is found in the Earth's crust. Indium has a few possible uses in LCD screens and other devices. Indium tin oxide is often used as a coating for screens and can also be used to make transparent electrodes inside the glass layers of an LCD screen. LCD manufacturing largely drives demand for indium. A US Geological Survey notes that it's also used in photovoltaic cells as the solar cell for DC. The metals compounds can be toxic, and people who have inhaled its indium tinoxide form in an occupational setting can contract a rare disease called Indian lung, which is an interstitial lung disease. Reports and finds. In an October 2020 paper, researchers led by Udit Gupta of Harvard University used publicly available sustainability reports from companies including TSMC, that is Taiwan Semiconductor Manufacturing Company, Intel Corporation, and Apple, to show that as computing becomes increasingly ubiquitous, so does its environmental impact. Now, the researchers concluded that chip manufacturing, as opposed to hardware use and energy consumption, accounts for most of the carbon output. So this is basically a graph of the greenhouse gas emissions from companies, and as we can see that chip producers like TSMC is overtaking automakers like General Motors as polluters. This is basically a graph showing the greenhouse gas emissions from a smartphone, where the 80% of greenhouse gases emitted during production, 16% from customer use, 3% from transport, and 1% for recycling. So now let's talk about the carbon footprint from electronics manufacturing. Computer chips may be in short supply, but the semiconductor industry's carbon emissions are plentiful. Now, what is carbon footprint? The carbon footprint presents the breakdown of combustion emissions within a manufacturing sector by end-use source. A team of researchers at Harvard University wrote in 2020 that chip manufacturing accounts for most of the carbon output from electronic devices. So we need to take a look at that. So this is the power consumption in kilowatt hours per 8-inch equivalent wafer mass layer. This is a report from TSMC, and as you can see, a lot of power is consumed. Next is water usage in chip manufacturing. An interesting fact is, chip plants in Taiwan called in water trucks earlier in the year 2019 to ensure supply during a drought because, by the absence of monsoon rains, TSMC's water consumption has increased almost 5-fold in the last decade, and in 2019 amounted to the equivalent of 79,000 full Olympic swimming pools. Using ISO 14001 to manage and reduce waste in the electronics industry. For many contract electronics manufacturers, the increased focus on reducing the environmental impact of their operations means reviewing all the stages of the production cycle. The 3 production cycles are pre-production, production, and post-production. So pre-production. This stage is mainly concerned with the supply of raw materials from mines. And when a company orders raw materials, is it ordering extra or just the right amount? What happens to that extra material after the production run? These are the main questions that the company should ask. Next is production. The main wastes in this stage is unnecessarily running machines or equipment, untrained employees leading to errors and material waste, non-conforming products requiring rework. Post-production. Under 4001, organizations must be responsible for the entire product life cycle. So they need to take care of the recycling, the disposal of with minimum harm to the environment, the refurbish or repair after post-production. Why does the ISO 14001 standard matter? ISO 14001 is an extremely beneficial standard for companies looking to up their environmental management systems. Adhering to ISO 40001 can improve resource efficiency, reduce waste, lower costs, measure environmental impact, gain a competitive supply chain advantage, increase business opportunities, meet legal obligations, and increase stakeholder and customer trust. Greenpeace campaigns. Greenpeace is an independent global campaign network. The network comprises 26 independent national or regional organizations in over 55 countries across Europe, the Americas, Africa, Asia, and the Pacific. Greenpeace had launched the Rethink IT campaign to challenge the IT sector to take responsibility for its rapidly growing footprint on the planet. Now a guide to greener electronics. A guide to greener electronics is basically an analysis of what 17 of the world's leading consumer electronics companies are doing to address their environmental impacts. Here is how the companies stack up. The first being Fairphone, the second being Apple, and the third being HP and Dell. These are the steps some companies have taken towards a greener future. Apple, all products are free of BFRs. So BFRs means brominated flame retardants, which are used in printed circuit boards. One example is TPVPA and PVC, polyvinyl chloride. Amazon, Oppo, Vivo, Xiaomi have no detoxing chemicals. Acknowledgement. I would like to thank Mr. SOUMYAJIT for giving me this opportunity, and I would also like to thank my parents and friends who helped me with this presentation. These are some of the websites I visited to collect my data. Now, this leaves us with one question. Is green electronics manufacturing even possible? Even while considering the challenges that are present here, it's quite clear that electronics manufacturing and similar industries have a net negative impact on the environment. So is the greener electronics industries achievable? So the answer is yes. It is possible to create a greener operation, but it will take some time to get there, and lots of innovative solutions to overhaul existing strategies and processes. Thank you, and I would like to mention that Intel had taken a firm stand in this and is using renewable energy resources like solar energy and hydro energy.